what is the importance of derivative? Basic thing is, what is differentiation, what is the need of it? Now if you are going in your own car towards a particular direction, let it be in a straight line or anywhere, okay. So if you are starting right in the beginning, let it be at 8 a.m. and you reach the spot where you have your destination, where it is, suppose you reach there at 1 p.m. after 5 hours. Now if I am asking you what was your average speed, then you can easily calculate it. You can just tell me that within 5 hours these were the kilometers which we have done. So this is the average speed. But if I ask you what was your speed at 9 past 10, okay, then you will not be able to answer. There the average speeds fails. So this is what, this is the miracle what we are going to find it. That is what given by the intuitive ideas of derivative. Now I am just going to give you an example for this part, same part, then how we can approach it for the right answers, okay. So let me give you first of all a very simple formula for the derivation, including the explanation, okay. Now imagine that, now we are just going with the same example which I gave you. Now imagine that the variable x, the variable x is the time and the value of fx is the distance travelled in time t, okay. Now let us imagine, we are just imagine that the variable x is the time and the value of fx is the distance travelled in time t. Then speed is equal to distance travelled upon time taken. So this is a very general formula which we are all normally using in physics, all these things, okay. Now now if the interval is small, one containing C, and we expect that the speed in that interval, we expect that the speed in that interval is the approximation or you can write it that we expect that the speed during that interval, okay, one at the same thing. Speed in that interval is the approximation of the speed at time C if time interval is C comma C plus H, okay, and here H can be negative or positive, it hardly matters, we can just write it where H can be positive or negative. Then speed in that duration is given by distance upon time. Now what distance is here? Distance upon time means what? Now this means distance upon time. Now how much distance? Distance travelled up to time c plus h minus distance travelled up to time c. Distance travelled up to time c plus h minus distance travelled up to time c upon divided by, now what is the time? That will be the length of time interval. Okay. So basic thing is, this can be written as, now we can write it fc plus h minus fc upon h. Okay. Now here, as h approaches to 0, then fc plus h minus fc upon h approaches to the speed at time c. Okay. So what we can write it now? We can write it, this is the symbol for derivative, this is the symbol for derivative, f derivative a is equal to limit h approaches to 0 fc plus h minus fc upon h. So this is the intuitive idea for finding the derivative. This is it. Okay. Now in the beginning I gave you an example. Let's go for an example now. And it will be very nice when you are understanding the example. Now, the distance ft. Now suppose the distance is ft in meters the distance ft in meters moved by a car along straight road in t seconds is given by ft is equal to, let it be t square plus 5t plus 4. We can write any of the equation here. So I have written, let it be t square plus 5t plus 4 find the car at the end of, let it be 5 seconds. Means how much distance the car has travelled within the 5 seconds if it is given by ft is equal to t square plus 5t plus 4. Now just look, as you started the car, now I am asking you, when you just started the car, what was, how much distance you travelled after, suppose it is 50 seconds. So 50 seconds or 10 seconds or 15 seconds, it means there should be some calculation. That's what we are going to use this formula. Okay. Now Now given ft is equal to t square plus 5t plus 4. Now the speed of car at end of 5 seconds will be f derivative 5. Now f derivative 5 means speed of car at the end of 5 seconds will be at f derivative 5. Now f derivative 5 is equal to limit h approaches to 0 f 5 plus h minus f5 upon h. Now according to this formula we will be proceeding like this. Now first thing is, let this be 1. Now f 5 plus h is equal to, now let us put f5 plus h in this part. In place of t, now we are going to put 5 plus h. So we are having 5 plus h whole square plus 5 with 5 plus h plus 4. Okay. So this becomes now 25 plus 10h plus h square plus 25 plus 5h plus 4. Leave it as it is. f5, now this will be 5 square plus 5 times 5 plus 4. Now this is 25 plus 25 plus 4. Now let us substitute in the question. Now we will be having f derivative 5 is equal to limit h approaches to 0. Now this part, now this becomes 25 plus 25 is 50 and 50 plus 4 is 54. 54 plus 10h and 5h. 15h plus h square minus 54 upon h. Limit h approaches to 0. Now here 54 and 54 cancels. We are left with h, 15 plus h upon h, and this is equal to 15 meters. Is it clear? Because h and h will be cancelled, we are left with 15 plus h, we are putting h is equal to 0, you have done in the limits. Now look how nice the example was. Equation was given to you and within 5 seconds how much you have travelled? 15 meters. So this is only possible if we are going with the ideas of the derivative.